In this video, I'll be discussing the criteria for selection of fits. Let's first take the example of hole bias system. So let's consider a H7 hole. The possible number of fits for H7 hole can be calculated as follows. The fundamental deviation of shaft can vary from A to ZC, which means there are 28 different categories of fundamental deviation. For each fundamental deviation, there are 20 IT grades, varying from IT01 to IT18, which means that the total possible combination of fits for a H7 hole will be 28 into 20. That comes out to be 560. So out of these 560 combinations, some will fall in the category of clearance fit, some may fall in the category of transition fit, and so on. For ordinary engineering purpose, only a small number of fits are required, as can be seen in the table. For the H7 hole, to make a clearance fit, we will use shaft having tolerance classes F6, G6, and H6. And if we want to create a transition fit using H7 hole, then the shaft use will be J6, K6, M6, and N6. Out of these also, the first choice for fits should whenever possible be made from the tolerance classes shown within the frames. Now the clearance fit can be further subdivided into many categories. The first example is H9E8. It is the example of a loose running fit. It is used in case of plumber block, bearing, and loose pulleys. So here we can see the example of loose pulley. In this figure, the driving pulley is fitted on the driving shaft and rotates with it. The fast pulley is fitted on the driven shaft and will rotate with the driven shaft. Whereas the loose pulley, which is having a loose running fit, will spin freely on the driven shaft. So when the belt is wound on the driving pulley and the loose pulley, the driven shaft will not rotate. But if the belt is wound on the driving pulley and the fast pulley, the power will be transmitted from the driving pulley to the driven shaft. So another example is H8E8. That is a easy running fit. This is used in case of grease lubricated bearing with medium revolution. Similarly, H7F7 is a normal running fit. It is used in case of oil lubricated bearings. So here we can see that both the grease lubricated bearing as well as the oil lubricated bearings are example of hydrodynamic lubrication. So depending on the operating speeds and the loads encountered, the hydrodynamic lubrication may be a grease lubricated bearing or a oil lubricated bearing. And depending on whether it is a grease lubricated or oil lubricating, the fit might be a easy running fit or a normal running fit. Another example is H7G6, which is a precision running fit. It is used in case of spline shaft and clutches. As the splined shaft and the clutch is supposed to move up and down frequently on the spline shaft. So the running is a precision running fit. Another fit is H7H6, which is a precision fit. It is used in case of milling cutter on milling mandrels. So here we can see the milling cutter and the milling mandrel fitted together, and notice the set screw used to secure the milling cutter on the mandrel. Now this precision fit minimizes the eccentricity between the milling mandrel and the milling cutter. Now transition fit is further classified into many categories. The first category is H7J6. It is a easy push fit. It is used between fast pulleys and the shaft and hand wheels and the shaft. Now we can see that the fast pulley, the fit between the fast pulley and the shaft is easy push fit, whereas the fit between the loose pulley and the shaft was a easy running fit. Then H7K6 is a push fit. It is used in case of inner rings of roller bearing on shaft. Then H7N6 is a lice press fit used for gears and worm wheels on their respective shafts. So next is the interference fit. Interference fit can be further classified into many categories. H7P6 is a medium press fit. It is used for between the valve seat and the body on which the valve seat is fitted. Then H7R6 is a press fit. It is used in case of medium drive couplings on the shaft. So here we can see the coupling attached to the shaft. The fit between the coupling and the shaft will be a press fit. And in addition to the fit between the shaft and the coupling, a key will be also inserted between the shaft and the coupling. Then the next is shrink fit, H7S6. It is used for permanent and semi-permanent assemblies. An example is the railway wheel and the axle. So in case of shaft bias system also, the preferable fits of the shaft bias system are shown in the table shown. This can be also classified into the three categories. And once we have specified the tolerances, we have to determine the convenient method of manufacturing to produce the component within the specified tolerances. The specification of machining method depends on the tolerance specified by the designer. So here we can see the tolerance grade from 1 to 16 are shown on the left side. So if we see at the bottom, the tolerance grade 1 is used in case of slip blocks and reference gauges, whereas tolerance grade 2 is used for high quality gauges. So the IT grade 1 to 4 are used for precision instruments. Here we can see the IT grade 4 is used for gauges, fits of extreme precision. So the IT grade 1 to 4 are used for instrument of precision instruments. The slip gauges are used to measure the length accurately. Similarly, feeler gauge is also a high precision instrument, and the IT grade must fall within IT 1 or 01, and it is also used to measure the gaps between, like the clearance between the tappet and the overhead cam in case of IC engines. Now further we can see here, the IT grade 6 can be produced by grinding and fine boring. Similarly, IT grade 10 can be produced by milling, slotting, and so on. So what we understand is that once the IT grades are specified, we can determine the machining method that is convenient to produce that specific IT grade. For example, if we want to produce the IT grade 7, or we want to create a hole of IT grade 7, let's say H7 hole. So it can be produced using diamond boring. In fact, diamond boring can also be used to produce a hole of IT grade 5. Or it can be produced using boring also. And boring can produce holes up till IT grade 11. So this is just a approximate figure table, but from here we can get a brief idea on the manufacturing methods to produce a specific engineering application, specific IT grades. So that's all for this video. Thanks for watching.